Hello everyone. I welcome you all for my discussion today on damped free vibrations. It is continuation of this discussion. In my previous class, I took a system. So all that what I discussed in my previous class, I have summarized here. So this is a kind of single degree freedom system which is called as a damped system. This is also called as spring mass dashpot system. We have a viscous damper here. In case of viscous damper, the resistance force offered by the viscous damper is directly proportional to the velocity. F is equal to C into x dot. So making use of all that, so assuming that I am having free vibrations, I wrote down the expression for differential equation, the expression for motion, and this is what we get: mx double dot plus c into x dot plus kx equal to 0. So as I told you that we are not happy with the derivation of the differential equation of motion, we want to know what is the solution and under what circumstances we are going to have vibrations and how the decay in vibrations is going to take place. That's what we are interested to study, and therefore I want to find the solution of it, and in an attempt that I assume this x equal to e raised to s, then substituted here and simplified, and this is what I got: ms square plus cs plus k equal to 0. This is quadratically s, and therefore I wrote s1 comma 2. Okay, after this I introduce a term now, what is called as critical damping coefficient, which is an imaginary value of damping coefficient which makes certain term equal to 0, and by simplifying that we got it what is called as a Cc value is 2m into omega n. If you substitute omega n, then you get Cc equal to 2 times the square root of k into m, the same thing, that is critical damping coefficient. Then I introduced one more term, what is called as damping ratio. That is the ratio of the actual damping coefficient in the system to the critical damping coefficient of the system. For every system, there will be something what is called as critical damping coefficient, whose value is this. So I followed the ratio. So depending upon what is this ratio, okay, then I classified the system into three categories: G greater than 1, G equal to 1, G is less than 1. And I modified this S12 expression in terms of zeta, and this is what we got: S12 is equal to minus zeta plus or minus root of zeta square minus 1 into omega n. And one more observation which I made after deriving this expression: what is this differential equation? This is a second order differential equation. Every second order differential equation shall have a solution whose general solution shall have two constants. That is very, very important. The general solution of this equation shall have two constants which can be evaluated using what is called as initial conditions. Okay, so now that is very, very important. Okay, one more last thing before I proceed further. So e raised to a plus b, where is this term? How did we get it? It is not that. I know that e raised to a plus b is same as e raised to a into e raised to b. So anything x raised to m plus n is what? X raised to m multiplied by x raised to n. So this is what you have studied in your school days. The same thing we are going to use in our analysis. And one more thing. So imagine that there is something which is going to vibrate between this. See, this is one extreme position, this is another extreme position, like that. It is moving like this, and this is what I call it as the mean position, or what we call as the equilibrium position. Okay, with respect to equilibrium position, we tell what is the displacement. Suppose the particle is here, then this is what I call it as the displacement. If I call this displacement as positive, then after some time the particle may be here. That time its displacement is negative. What I mean is, if anything has to vibrate, then its displacement must vary positive, negative, like that. So if you cannot have the displacement positive, negative, that means that thing is not vibrating. If it is moving in only one direction, all the time its displacement is either positive or it may be only negative. So if it is either positive and negative, positive, negative, if it is changing continuously, then only we say that it is vibrating. If the displacement sense, that is direction or what sign, is not changing, then we say that it is not vibrating. That is very, very, very important observation. Similarly, if this is a simple pendulum, it has moving like this is one extreme position, this is another extreme position. If this is my positive theta, then this side, any angle, any displacement, this side I indicated negative. Then only if I have positive theta and negative theta, then only I can say that I have vibrations. Otherwise, no vibrations. Very, very, very important. I hope you understand. And I shall keep it as it is. Then, as and when I require, again I shall come back. I shall start with the first case. What is that? Overdamped system. The system is overdamped. The system what I have here is K, M and C values are such that zeta value is greater than 1. Overdamped system. That is zeta is greater than 1. Okay, let me quickly go through. Okay, now zeta is greater than 1. That means C is greater than CC. Okay, doesn't matter. Now S1, 2. Alright, we write down what is S1 and S2. What is S1? So S1 I consider smaller than S2. Therefore I shall take minus sign. This S1 is equal to minus zeta minus root of zeta square minus 1 multiplied by omega n. And what is S2? S2 is equal to minus zeta plus root of zeta square minus 1 multiplied by omega n. Okay, so now this, if S1 and S2 are these values, then please remember what is our solution? Our solution is x equal to e raised to st. Now what is the general solution for this? General solution, x of t in general, or which is simply called as x. This is equal to C1 into e raised to S1t plus C2 into e raised to S2t. Because C1 and C2? C1 and C2 are two constants which are necessary because it is a second order differential equation. So this use has to be under mathematics. You already know it. I shall not go into detail about that. Okay, let me substitute now. C1 as it is. What is e raised to S1t? That is nothing but e raised to minus zeta minus root of zeta square minus 1 into omega n into t. Similarly, plus C2 into e raised to minus zeta plus root of zeta square minus 1 into omega n into t. This omega n into t I shall take within the bracket. Okay, then I shall have e raised to minus zeta into omega n into t minus this into omega n into t. Okay, this is what I have. E raised to minus a minus b can be written as e raised to minus a into e raised to minus b. The same thing I would like to do it in one stroke. C1 into this I can write it as e raised to minus zeta into omega n into t multiplied by e raised to minus root of zeta square minus 1 into omega n into t. These are not within the square root sign. This is first term. Similarly, the second term C2 into e raised to minus zeta omega n into t multiplied by e raised to plus root of zeta square minus 1 into omega n into t. Okay, now, so I have e raised to minus zeta into omega n into t. This is there and here also is there. I shall take it out. And what is remaining? C1 e raised to minus root of zeta square minus 1 into omega n into t. This term plus C2 into e raised to plus root of zeta square minus 1 into omega n into t. Alright. or even a square bracket is sufficient. Okay, observe it very carefully. Okay, so what is zeta? Zeta is damping ratio, its value is more than 1. Zeta is not changing. For a given system, zeta is not changing. It is not going to depend on the time. So right now zeta is so much, after 1 hour zeta is so much, it is not changing. Zeta is a constant. And for a given system, omega n is constant. Omega n is the square root of k upon m. So you have a system, what is its k, what is its m? Then omega n is constant. So zeta is constant, omega n is constant, t is the time which is changing. So t will never become negative. T, if you start now, right now you can set your clock, t is equal to 0. So maybe after 2 seconds, after 3 seconds, after 10 seconds, after 1 day, that means t is always positive. T will never become negative. Okay, similarly, C1 is a constant which is not going to change its sign. C1 is a constant throughout now or after 10 days, after 10 years, C1 is remains same. C2 is also constant. Same thing here, same thing here. Okay, so now imagine if t is equal to 0, then this becomes 1, then this is 1, then you have C1, then you have C2, C1 plus C2. If t equal to 0, then it is C1 plus C2. That means the sign is not changing. Okay, then what t is something, say t is say 10 seconds, something like that. You substitute t equal to 10 seconds, then you have minus zeta something, omega n something, t is 10, then e raised to minus something, e raised to minus something is some value, and this is not changing its sign. Please remember, e raised to minus zeta into omega n into 10, after 20 seconds 20, that means e raised to minus only all the time. This will not change sign for different time. Check this also, e raised to root of zeta square minus 1, this is a constant, omega n is a constant, and t is only always positive. This doesn't become e raised to positive and e raised to negative. T is always positive, and whatever is this, that into minus, this is some always positive, this also is positive, therefore e raised to minus only. So what it means, this also is not changing its sign, plus minus. And similarly, this also is not changing. This term is not changing its sign. This term is not changing its sign. Sign means plus, minus, sometimes plus, some for some values of t it is plus, for some values of t it is minus. That is not happening here or here or here. So what does it mean? So this means that x of t for all t not changing its sign, What does it mean? If it is not changing its sign, as I was telling here, that means no vibrations. That means we cannot have vibrations of the type what we are discussing, that is free vibrations. For overdamped system, free vibrations will not take place. That is the observation. Okay? So no vibrations. I hope you understand. For overdamped system, we cannot have vibrations. So if there are no vibrations, then it has no role in the study of vibrations. Our aim is to study vibrations, and this case will not produce vibrations, and therefore this is the end of it. But from the examination point of view, they may ask, okay, so get the expression for this kind of expressions, giving your system that it is overdamped system. Later on I shall take questions from the examinations which has appeared, and then we may come back. So I expect you to remember these expressions. Sometimes it is substitution like thing, problems may be asked. Therefore, I wish you to remember this. So now, the first case is over. Now I shall take up the second case. What is that second case? The second case is, what is that? Critically damped system. The system is critically damped. What is the meaning of critically damped? Zeta is 1, critically damped system. What is that? Zeta is equal to 1. Zeta is equal to 1, that means C is equal to CC. Okay, no problem. So let me write down what is S1. S1. Let me write down here. It is minus zeta. Zeta is 1, therefore it is minus 1. Plus or minus. So S1 means minus 1, smaller value. Square root of zeta square, which is 1. 1 square is 1. Minus 1. This multiplied by omega n. And what is S2? S2 is equal to minus 1. It is plus sign. Root of 1 minus 1 multiplied by omega n. So what is S1? S1 is minus omega n. And what is S2? S2 also is equal to minus omega n. So therefore S1 and S2 are coinciding, are one and the same. Therefore I can say that S1 is also equal to S2 is also equal to minus omega n. Very different. Okay. So this is the case when the two roots are one and the same. The two roots are one and the same. Then we have a different way of writing what is called as the general solution. If two roots are different, distinctly different, okay, as in the previous case, we wrote the general solution as C1 into e raised to S1t plus C2 into e raised to S2t. But here I cannot write like that. If I write what is that C1 into e raised to S1t, if I try minus omega n into t, then plus C2 into e raised to minus omega n into t. If I write like this, then it is e raised to minus omega n into t into C1 plus C2. C1 is a constant, C2 is also constant, then C1 plus C2 is also a constant. This is equal to e raised to minus omega n into t. It is not two constants, we end up with only one constant. So because of this, we know that the general solution has to have two constants, and therefore this is wrong. So because if I write like this, I end up with only one constant, and I had made in the very beginning the general solution of this must have two constants. So that means this is wrong. That means there is some other way of writing it. How to write it? It is written like this. It is C1 plus C2 into t. This is what you have studied in your differential equation study. I am not writing it. C1 plus C2 into t into e raised to minus omega n into t. That is nothing but S1 equal to S2. This is how we write it. Okay. C1 plus C2 into t e raised to minus omega n into t. This is the final expression for. Here I don't have to substitute anything. Zeta is 1. This is final only. Okay. So now check it. Okay. Whether this term can change. X of t can become, for some values of t it is positive, some values of t negative. Is it possible? Check it. Okay. C1 is constant. That will not change sign. So now or after 10 minutes or after 10 days, C1 value will remain same. It doesn't become positive, negative, changing. Okay. Then C2 into t. See, what t is always positive only. 0, 10, 20, 15, 30 seconds like that. This is positive. Then whatever is the sign of C2, the same is the sign of this term. That means, so now for different values of t, this term is not changing its sign. Okay, C2 is constant, t is always positive. Then whatever is the C2 into t, okay, whatever is the sign of C2, the same is the sign of C2 into t for any value of t. This is not changing, this is not changing, and what about this? This also will not change. e raised to minus omega n, this is a positive value, 10 radians per second to 8 radians, something like that value. That into t, this is positive always. Okay, this into this is positive all the time, and all the time e raised to minus something. E raised to minus something is always some value only, that is not changing its sign, positive, negative. Therefore, for all t, x of t is not changing its sign. It is not changing its sign. So what does it mean? So the conclusion is no vibrations. If the system is critically damped, please do not forget what we are understanding. What is by critically damped? The value of C of the system is same as Cc. What is Cc? Cc is 2m into omega n, any value. If your C value and Cc value are same, if you try to induce free vibrations, then the free vibrations will not take place. That is the meaning of it. So I hope you remember the purpose of study of this topic. So I told under what circumstances we are going to have vibrations, under what circumstances we are not going to have vibrations. That's what we have studied in the two cases. So in the third case, when I take the underdamped system, definitely the vibrations are going to take place. So therefore, in underdamped system, we are going to have vibrations, and that case I shall discuss it in the next class or next session. Welcome you all for another session and a very important topic of our damped free vibrations. Okay, so a case what is called as underdamped system, and this is a case where we really have vibrations. That's what I intend to prove it. Underdamped system, and we all know that zeta is less than 1. And let me write down what is the value of S1. Okay, go back and let me write down minus root of zeta square minus 1 multiplied by omega n. And similarly, S2 is equal to minus zeta plus root of zeta square minus 1 multiplied by omega n. Okay, so please remember what is your zeta? Zeta value is less than 1. So zeta is value less than 1. Say for example, for simplicity, assume that zeta is equal to 0.5. So what will be zeta square? Zeta square 0.5 square is nothing but 0.25. That means if your zeta is less than 1, your zeta square is still smaller, less than 1. Remember here, zeta square is less than 1. Less than 1 minus 1. What do you get here? This is minus. Square root of minus. And this also square root of minus. So what do you mean by that? S1 and S2 are imaginary. Do you agree? They are imaginary. Imaginary and different. That means S1 and S2 are not one and the same, they are different. So S1 and S2 are same in case of critically damped system. For overdamped and for underdamped, S1 and S2 are different. In overdamped system, S1 and S2 are real, they are not imaginary. In critically damped, S1 and S2 are one and the same, but they are real. But in this case, S1 and S2 are different, but they are imaginary. So now I would like to introduce what is called as imaginary term, that is nothing but say J term. J I shall equate it. The square root of minus 1 is equal to J. Okay? So now S1 I shall rewrite it. S1, what is S1? This is minus as it is. So within this square root I shall take minus sign. This is minus as it is. So this I can write it as minus 1 into bracket into bracket 1 minus theta square. Check here. Square root of minus 1. I have taken minus 1 outside. If I take minus 1 outside, it is 1 minus. You can take it inside. Minus 1 into 1, minus 1. You have as it is. Minus into minus, that is plus. The same thing. Okay. This multiplied by omega n. Okay, I shall simplify this and then straight away, without doing for s to all that, I shall straight away write this is nothing but minus theta. This is minus. Okay, square root of this is nothing but root of minus 1 into root of 1 minus theta square multiplied by omega n. Okay, this is nothing but root of minus theta. Then what is this minus 1? Minus j into some people, some books call it as I also. So I or j, whichever you are comfortable, you can take that. I am writing it as j, assuming that you are also comfortable with that. So if you are not comfortable, please replace this j by I. I want you to write it down in your paper. Please refer to my books or my video several times. Please make your own notes. You may not get notes later on for the IIT test. Please make it now only. So j into root of 1 minus theta square multiplied by omega n. And so I shall straight away write s2. What happens? s2 is equal to minus theta plus j into root of 1 minus theta square multiplied by omega n. Very, very important. So this is your s1 and this is s2. Okay, so now once I know S1 and S2, now I go for what is called as general solution. What is general solution? X of t is equal to C1 into okay e raised to S1t. Okay, Ce1 into that is S1, that is nothing but minus beta minus j into root of 1 minus theta square into omega n into t. This is nothing but C1 into e raised to S1t plus C2 into e raised to S2t on the same line. C2 into e raised to minus theta. Now it is plus j into root of 1 minus theta square into omega n into t. Okay? As usual, as I said, even into this omega n t, I shall take it out within the square bracket. What I did in the overdamped system, the same similar thing. This I can write it as C1. This e raised to minus theta into omega n into t into bracket e raised to minus j into root of 1 minus theta square into omega n into t. So e raised to a into e raised to b is nothing but e raised to a plus b, the same thing what you get. Plus similarly c2 into e raised to minus theta into omega n into t into bracket e raised to plus it is j into root of 1 minus theta square into omega n into t. Okay, so as usual, so e raised to minus zeta omega n t. I shall take it outside. E raised to minus zeta omega n into t into bracket C1 into e raised to minus j into 1 minus zeta square into omega n into t plus C2 into e raised to plus j into root of 1 minus zeta square into omega n into t. Okay, close. Okay, so now root of 1 minus zeta square into omega n into t omega n. Okay, this root of 1 minus zeta square multiplied by omega n, I shall call it as omega suffix dn. Meaning is damped natural frequency, omega dn. Okay, so I shall substitute this. So I make use of this space. Okay, so let me continue. What is that? X of t is equal to, what is that? E raised to minus zeta omega n into t into bracket. Okay, so what is the C1 as it is, into e raised to minus omega dn, j is missing, no? E raised to minus j into omega dn into t plus C2 into e raised to plus j into omega dn into t. Okay, so now I shall come back here. E raised to j theta is nothing but cos theta plus j sin theta. Similarly, e raised to minus j theta is cos theta minus j sin theta. This is what I would like to make use. What is that? E raised to minus zeta omega n into t into bracket C1 e raised to minus j, the whole thing is theta, omega dn into t, that is theta. What is that? That is equal to cos theta. It is cos theta. Cos theta is omega dn into t. It is e raised to minus theta, therefore this is minus j into, what is that? Sin of theta, omega dn into t. This is one term. Plus C2 into bracket, okay, cos of omega dn into t plus sin of omega, it is j times sin of omega dn into t. Okay, so now this is same as e raised to minus zeta omega n into t into bracket C1 cos omega dnt. Here also C2 cos omega dnt. So I shall take cos of omega dn into t common, and therefore it will be C1 plus C2 into cos of omega dn into t. Okay, here C1 into minus j into this thing. Okay, so therefore sin omega dnt, that's what I would like to take common. Say plus, I shall write it. Okay, what is this here? C1 into minus j. Okay, j I shall also take. This is minus C1, and here C2 into j. This is plus C2 plus C2. J is C2 into j. This is into sin of omega dnt into t. Okay, so now C1 and C2 are constants, and therefore what I do is e raised to minus zeta omega nt as it is, no change. This into bracket. C1 plus C2 is another constant, which is a into cos of omega dn into t. This j into C2 minus C1, j into C2 minus 7, the whole thing is another constant, and that I shall replace it by b. What is b? B is j into C2 minus C1, b into sin of omega dn into t. Okay, this is what? This is x of t. The displacement at any time for underdamped system is given by this. So observe here carefully. You have cosine term and sine term. They make obvious. For sin theta, sometimes it may be positive, sometimes it may be negative. This may be positive, negative. This may be positive, negative. Okay? So therefore, since for different values of t, x may be positive, x may be negative, and therefore for different t, x of t may be positive or negative. So what does it say? This means we have vibrations. This means we have vibrations. So underdamped system will result into free vibrations. Shall provide, can have free vibrations. We can have free vibrations. So please understand here, this is free vibrations. The same equations x of t can also be written e raised to minus zeta into omega n into t. So here cos of omega dn into t and sin of omega dn into t. Okay, cos theta and sin theta, something like that. Cos theta can be replaced by sin theta, or sin theta can be replaced by cos theta, and so this can be written as, say, into one constant a and b. I can replace it by one constant, say maybe at the beginning here, c into bracket c into e raised to minus zeta omega n t into sin of omega dn into t plus phi. So please remember, in this equation also we have two constants. One is c, the other one is phi. Phi is called as phase difference. This can also be written as, instead of c, another constant d, e raised to minus beta into omega n into t into, I don't want sine, I am happy with cos, that cos of omega dn into t plus alpha. So here alpha and d are constants, here phi and c are constants, here a and b are constants. All these three equations are one and the same. Okay, so this is, we have a case of what is called as vibrations in case of underdamped system. Very, very important stage we have reached. Very little theory is remaining. What is that? So at what rate the amplitude is going to decrease, and that part of discussion is under what is called as logarithmic decrement. So what is logarithmic decrement? How do we define it? And what is the use of it, etc. All that we shall study in our next class.